Hello, coders. So today we will discuss about sigaction, why sigaction is preferred over the signal API, which we used in the last video to catch a signal from a process. We'll also see how to use sigaction in our program. Okay, so if you see here, so I list some of the points that make sigaction a better choice than signal. So first one is a portability. Okay. So SIG action is more portable than signals. So signals are just for the testing purpose earlier in in the older systems. So in the production environment, we are not using signal. In spite, we will be using SIG action. And as we know, SIG action is also thread safe. Can easily use within the thread without doing much overhead over it. And we have extended info on sig, on the signal. So for example, we have sig info underscore t structure that give us much more info that we get in the signal because the signal, as you see, only have two parameters. So first is the signal which we want to register, and second is a handler. That's all. So, but in here we will be passing a structure to the sig action that will do action over it. Okay. So, what are the major problems that is overcome by sig action when signal? So, till now we discuss why it is preferred, but what are the problems? So I have listed few problems. So first is a auto reset issue. It means, for example, if you register the signals in the old system V, and at that time when a signal is delivered, you need to re-register that signal using the signal MPI in the handler itself. Okay. And if you don't do that, that signal will only be delivered once. And next, when you again send the signal, your program will be terminated and won't handle it. Okay. So, for example, I'll show you one simple example where I have registered a signal SIGINT, that is control C with a handler. Okay. And here in the handler, I'm using SIG that won't let this handler to operate again. And here we are painting chord signal. So let's see the behavior. So I'm just replicating the behavior in the older system. So I'll talk about what is there in the new system. Okay. So if I make it run, so let's see what will happen. Hyphen O, then we have sig and signal.c. If we run sig, okay, so it is showing running and press control C. If I press it, control C, got the signal. Okay, and if I again do control C, your program will be terminated. So that signal is caught only once. Okay, so next time you need to re-register. So in spite of doing this, if I put again the handler, okay, so I'm re-registering my signal in the handler and let's see the effect. So I again run it, and if I do control C, it is caught. Again, if I do control C, it is again been caught. Okay, so here I'm just re-registering my signal. So this is the behavior in the old system. Okay, so I hope you understand what is auto reset issue in system B. Okay, and one problem we are having in this handler is once this handler is delivered, for example, if one first time we enter control C and this handler runs, after that, when we re-register this signal, so at the same time, after entering this function again, we get again a control C. So this handler will not handle it in spite this process get killed. Okay, so this is the problem where you are not blocking all the signals when you enter this handler. Okay, so that is blocking signals in handler. If you won't do that, your process will be killed. So it's not there in signal earlier, but it is there in sig action. Okay. So the third thing is restart system call using as a restart. So, for example, we have some system call that is in the blocking state. For example, read accept. Okay. And the process is waiting for some event at read or accept. At the same time, you get a signal. In spite of serving this read, it will go for the signal and your read or accept this API will get failed and you will get EI and PR error. So this is the problem with signal and that is overcome in sig action. Okay. So now you understand due to these three problems, we are not using signal. In spite, we are using sig action. Okay. And in sig action, we have this structure where we have, a function pointer to the handler. We have this sig action info. Okay, we are inputting some info here. We have some mask and we have some flag. We'll discuss it later in this section. Okay, so let's start with using the sig action. So sig action API, we have sig action we are using as an API. Then it will have actually three arguments. So first is a signal number. So we have sig in. Next is structure and structure sig action. Okay, and we have, for example, I'll put it say now I need to fill this function. So first SA dot we have SA underscore handler. If you see here, we have a function pointer here. So handler is equal to will give the address of our handler. Okay. So this is first thing. So we map our handler to this structure parameter. And second thing is we need to mask each signal. Okay. So next I will put say dot say underscore flags is equal to zero as it. Okay. So once I fill the structure, I need to pass the structure to here. So we have SA and third parameter I will be taking null for now. So let's compile this. I will take signal 1 for this. Okay, and here when I do sig 1, and if I do control C now, the signal is got. Okay, signal is got. So we don't need to re-register it. Okay, so this is one thing. Okay, so next, as we discuss, for example, we are reading. I will remove this option. Okay, and I will take size of underscore t n is equal to read, and here we have std in file number comma buffer, and we have the size of buffer here. Okay, so I am reading some data from std in, and I will be waiting for std in, and here if I have n points to less than 0, and I will use printf, and here I will take read field. So read field. Okay, and else read success. So else part is copy this and read success. So simple as that. Okay. So what happened here? After registering of the signal, second, we will be reading. Okay. So this thing is a blocking call. So it will block here and, expect some data from the input from the std in. And if we are able to read, it will give read success, whether read fail. So what I will do, I'll just compile it to second. Okay, I don't have buffer, so let's take a buffer of 100 bytes. So character buffer 100. Okay, and now again, if I run it, so it's a blocking call, so it will block a certain location. So once you enter, you will get read success. So I'll put it again. Okay. So it's a blocking at the read. And what I do here, ps hyphen grep sig star. Sorry. So I have to take ps hyphen ax. So if you see here, sig2 is there. Okay. So what I will do here, I will do skill hyphen sig in to this process. Okay, so just send the signal. So if you say here your read got failed. Okay, so it is the same case with SIGINT. Okay, so how to resolve this? So this flag, what I will do, I'll take SA restart. Let's see again. So I will take sig 4, and when I run it sig 4, and here again I will check the process. sig43631. So kill hyphen sig int process. Okay, so if you see here, you get the signal, and this time your read is not failed. Okay, so now I have the signal code. So if you see here, I don't have that sig underscore DFL flag to remove the registration here. So if I compile it again, original sig, and now if I do this signal, and if I press Control C one time, second time, third time, so it's registering. Okay, but as we discussed, the signal should not re-register without re-entering it in the handler. But it is working. So why this happens? Because in the new system, if you see, so I will take you to asterisk to check the system calls that has been used in SIG. So if I run this, okay. So if you see here the list of system calls, and if you see here internally the signal call is using SIG action, okay, and it is registering like same we discussed with SIG action. So they have SIGINT register and they have SA restart, restore, everything is there. So in the neurous system, we just taken the signal as a wrapper to SIG action only. Okay. So that's why your signal call is also working because internally it's using SIG action. So this is how we know. So this is all about this video. See you in the next video. Thanks.